Hello, my name is Carter Benson. I'll be presenting our work on creating a ontologist GPT called My Ontologist. The name of the paper is My Ontologist Evaluating BFO-Based AI for Definition Support. Paper is written by myself, Carter Benson, Alex Scully, Austin Liebers, and John Beverly. There seems to be a growing interest in leveraging ChatGPT to create ontologies. I think the reason why is clear. It's the potential for automating ontology development. Ontologies are hard to build, definitions are hard to write, axioms are hard to make, protege is clunky to use, right? So the urge to use ChatGPT to make ontologies, I think, is prevalent. But there's an issue, right? We without proper guidance, without extending from ontologies that already exist, without giving those ontologies to the GPT, which is insulated from that work, uh, we're going to make data silos. And here, by data silo, I just mean a collection of data that's inaccessible to other parts of an organization or uh, uninteroperable with other data. So without proper guidance, we can lead to fragmented and non-interoperable ontologies. And I take that to be uh, counter to what the core principles of ontology development are. One of the things we're trying to do is make data interoperable. It should be unsurprising to people that the out-of-the-box GPT can create syntactically correct RDF triples. By that, I mean it can use a turtle serialization, XML serialization, JSON serialization to create basic ontology classes and properties. However, this lacks domain-specific expertise, so it cuts out the domain expert in order to clarify what it is that domain experts are talking about in a given area. And it may produce logically inconsistent and incomplete ontologies. So you communicate with the same GPT over several days to build out an ontology of classes, but the GPT's memory is being reset. It's not constantly going back and seeing what it said before, so it will eventually start to be inconsistent. And it's also not defining out of the definitions that it's giving the component parts of the definition that should probably be in the ontology as well. And it needs explicit guidance for adhering to standards like BFO. So it needs to be told to extend from BFO or extend from Tupper or from Dolce. But even then, it might not be extending in the right way because who knows where the information about BFO is coming from. Maybe it's searching the web, but we can't be certain that it's searching the right area of the web or extending the right BFO file. So here's an example of what the out-of-the-box version can do. Here it was asked to describe a person named Alice using Turtle. And as we can see, it generates Turtle code. It's prefixing correctly. It's using Turtle syntax correctly. And then it tells you what it does. So given the amount of coding that coding GPTs that exist available through ChatGPT or through OpenAI, I don't find it surprising that GPT is able to do this. But what this does make me wonder is if we can create a ontologist using the build your own GPT function given to us by OpenAI. And what that does is it allows you to train your own GPT. You can connect files on the back end. You can give it prompts. You can tell it what sorts of questions it can start off as those little text boxes. It allows you to make customizable GPTs, and this is what my ontologist was built using. Uh, the rest of this presentation will be about different iterations of what my ontologist ended up being. Here's what the back end looks like. You're able to, in this text box here on the bottom left, you're able to tell the GPT exactly what you want it to be able to do. So if you wanted to make a GPT that will explain to you football rules, you could tell it you're a GPT that's going to only explain football rules to me. And then on the right side here, you can ask it questions. So what's a quarterback do? And you could put that into the GPT message, and it'll show you what the preview is. And here's what the other screen looks like on the back end. So this is the configure screen. This is where you can put the name of the GPT, the description, the conversation starters. But for us, the most important thing here is the upload files. That's where you're able to upload up to 20 PDF files that the GPT will look at when answering questions, and it'll draw information out of those files to then provide the user. Which brings us to My Ontologist 1.0. The goal of My Ontologist 1.0 was to generate BFO conformant ontologies. Not just that, though. It was to allow domain experts to build BFO conformant ontologies without the aid of a BFO trained ontologist. It was given Building Ontologies with Basic Formal Ontology, the book by Barry Smith, BFO 2.0 User's Guide, BFO 2020 Serialization, and Learning Sparkle by Bob Ducharme. It was fed prompts and provided feedback based on what it said. Importantly, I cannot stress this, the turtle file was changed into a PDF because ChatGPT cannot read turtle files. It will pretend that it's reading the file, but then when you ask it directly if it's reading the turtle file, it will say no. So we provided it with the PDF file. The purpose of each one of these was pretty simple, of each one of these resources. So building ontologies with basic formal ontology, the GPT was meant to take the principles of building ontologies using BFO. From that, it was supposed to take information about how to use the classes from the user's guide. It was supposed to take the turtle code and reuse it and extend it. And it was supposed to use Learning Sparkle for the more technical side of ontology development. So what exactly Sparkle query is, what shackle constraint is, the difference between owl and turtle and XML. So that was all supposed to come from Learning Sparkle. The issue with 1.0 was that it wanted to explain to the user how to make a ontology and not do it for them. So you would ask it, define human, and it would tell you about perspectivalism and granularity. It would not actually just make a definition of human as a material object. I think this was because it overweighted the textbook. It really wanted to just look at the textbook and not look at the actual ontology development things. And I am happy to report that I deleted it proudly. However, upon writing this paper, it would have been nice to still have My Ontologist 1.0 to still ask it some prompts to get an example of this. This is just from my memory and how frustrating it was to use. This prompted the creation of My Ontologist 2.0, which the objective of this one was to improve handling of downstream BFO classes. So instead of extending directly from BFO, we thought that it'd be a better idea to extend from CCO so that it's not recreating classes like human. Human is in CCO, human is not in BFO. So if you ask it to model human, it should just use the CCO definition rather than the Common Core Ontology definition, rather than creating a definition out of nowhere. So this time, we provided the BFO 2020 turtle serialization, BFO user guide, the entirety of the Common Core Ontology suite, so that's 12 ontologies or so, and a couple academic papers. The hope of the academic papers was that it would pull on definition creation principles out of the academic paper and kind of make rules on how to create ontology definitions, or at least BFO conformant definitions on its own. So altogether, we attached 20 PDFs. It was a lot of academic papers, and provided it feedback on responses again. It turned out that the knowledge base on this one was unwieldy, frequently crashed. It crashed a lot. And because the CCO suite document was over 1,000 pages long, I think that it would stop searching at a certain point and just give up and not go more than like 200 pages deep, for instance. in the document before it just gave you a class. And then it would not want to extend further. And aside from the CCO document being too large, making it too difficult for the GPT to pinpoint any classes, and making the GPT crash, the academic papers didn't have the uh, desired effect. Turns out that it was not drawing inferences based off of what was in the paper of how to create BFO conformant definitions. The academic papers instead had a similar effect to what the original textbook had, in that it was explaining a lot instead of doing. This to the My Ontologist 3.0. This was just an attempt to achieve a stable and informative ontology generation. The goal was to more make where 3.1, the idea was to make a BFO conformant ontologist that a domain expert could use to build out an ontology. This one was for an ontologist to use as an aid in creating ontologies. So we went from this lofty goal of cutting the ontologist out altogether to now making a GPT that can work with the ontologist to more efficiently create ontology classes and to not crash constantly. The resources given on this one were BFO 2020, and each CCO ontology file was kept separately so that the length of the file did not become unwieldy. So it was like 12, I think, ontologies that were connected on the back end that comprise the CCO mid-level ontology, and 36 explicit rules for ontology creation. I have some examples of that on the next slide. And the first order logic formalizations of BFO 2020. The idea there is to give the GPT more insight into the actual logic of BFO, not just the OWL representation of BFO. OWL is not as expressive as first order logic. So there's only so much you can actually tell the GPT to do using OWL, whereas the first order logic is much more expressive and we're able to say more. So that's why the first order logic was given to the GPT as well. This time we focused on clarity, coherence, and adherence to Aristotelian definition structure. So that's B is a C that D's, where B is the thing you're defining, C is the subclass to which it belongs, and D is the differentiating features. This was put into the rules that were used to govern the creation of classes and properties. There was significant improvement here. It would ask disambiguating questions. So if it was confused in what the user meant, it would ask for more information or for context. Slide. These are not examples of the rules, but this is what the back end of My Ontologist 3.0 looks like. So we can see all of the ontology files that are attached. We can see rules.pdf up there in the middle. Also attached is the modal relations ontology, which is not actually part of the BFO mid-level ontology suite, but it was there, so I gave it to it. And note here in the capabilities that web browsing is unclicked. I did not want this GPT to be searching the internet. It will often want to search the internet before it looks at its knowledge base, and the internet is not the reliable resource of information on CCO. Here's an example of some of the rules that were given to My Ontologist 3.0. So use precise language, keep the ontology modular, so you can update blocks, align with standards, so align with BFO, align with CCO, and to periodically review. So through the process of modeling a domain, occasionally a class that has already been defined would need to be changed a little bit to now align with the new information that you've gotten out of GPT. So it will, or out of My Ontologist. So we'll go back and periodically review definitions that it's already made during one dialogue length. Here we can see how ChatGPT does compared to Kubrick. Kubrick being the original developers of the Common Core ontologies. The request to Kubrick was to provide definitions that extend from a class in CCO but are not in CCO. So here we have apartment identifier, vehicle bed mount, and active booking. As you can see, Kubrick's definition is tidier. A code identifier that designates an apartment, that's an apartment identifier. Whereas My Ontologist is a little bit more rambling, but note that it gets the BFO definition structure correct, and it gets the parent class correct. And with a little bit more prodding, it could probably get closer to the Kubrick definition. Vehicle bed mount is already relatively close to the Kubrick definition. And then active booking, that is the subject of the next slide. You can see the tremendous difficulty that my ontologist had in defining active booking. So the first couple prompts, it gave a bad parent class, and I encourage you to pause the video here if you want to really look at what's happening here. Where I want to direct your attention to, though, is involves, where it gives a BFO IRI to involves. BFO does not have involves in it, so it lies here. It just directly lies about what this object property is. That's actually the object property for participates in, but it changes the name to involves, uses it in this definition, and then tells you that it has an IRI in BFO. So this is not the best thing that could have happened. And then it crashed immediately after, and then I was able to get a definition out of it that was usable. Release of GPT-4o, my ontologist became functionally useless. It ignored all the documents that were in the knowledge base and only searched the web, even though the web box was still not selected. And it has since then been fixed to where now it's not searching the web again, and it is consulting its knowledge base, but it does have a tendency still to create fake object properties. And it needs a user who's well versed in CCO and BFO to point out that it's making fake object properties. Here's what happens when you ask it to model address. It tells you exactly what it's going to do. It tells you what it needs to define, and then it writes this code. And note that it creates a class, which is a type of information content entity. That's address. That's good. But then it creates all these object properties, all these single-use object properties. And it basically treats the ontology now like a key value database. It looks like, to me at least, where it has state, and then you have a state. It has postal code, and then you have the postal code. That is not the way that we should be defining these things according to CCO. But with some prodding, we can still get close to what CCO wants us to do. So instead of it just being an ICE, it's now a designated information content entity. Street name is now an ICE. Fine, we can accept that. Street number is an ICE. Where it still struggles is that it wants to attribute a text value to an ICE, which currently in CCO we cannot do. We can only attribute text values to information-bearing entities and then say that those information-bearing entities carry ICEs. So it still violates the design pattern of CCO, just not to the extreme that it was before. This is still at least workable, and we could continue to go with this variation to get something that is actually CCO conformant. Overall, the results are mixed. There's the potential here for LLMs to assist in ontology creation, but there's persistent challenges in complex tasks and adherence to conventions. It really wants to just do its own thing, regardless of how many times I tell it to follow strict rules. So in the future, I would like to see the rules get better. I think the rules do still need some work done to them, but also more importantly, I think there needs to be work done on getting the GPT to more strictly adhere to standards that are given to it, whether those are ontological or some other standard. The GPT really just wants to do its own thing. It doesn't want to look at the knowledge. It'll search the internet before it searches the knowledge base, and it presents information to you as if it is accurate without hedging itself, without any inclination or any sign, we'll say, that it is lying to you. Thank you.